who've been in the industry for at least 10 years. And we realized during this course of time that there's a big disconnect between what the industry expects, and what is taught in the academics. And thus, we thought that as our way of giving back to our alma maters and other educational institutes, we decided to hold these web series, which are free of cost, for the benefit of students. Though I even see professors have joined, so I'm not sure how that will go, but it's good to have everyone on board. So that's the whole idea of BridgeNBeyond. We intend to take workshops which are specific to particular topics, for example, machine learning or data science, and even deeper into each of the topics. So any of you guys who are interested in contacting us, you have our email addresses and you can contact us. So this web series is going to be a part of at least 10 talks. I think we have mentioned 9, but due to a lot of demand from a lot of people, we've added another session called Ask Me Anything AMA that we intend to conduct on next Sunday. I will be sending out a Google form. Any questionnaires, any questions that you believe are unknown to you can be added. About the webinar, by default, everyone's on mute. However, you can ask your Q&As. There's a Q&A option below. So you can ask your question. You can send your question in the Q&A option or on the chat. Alternatively, you can even raise your hand. There's a raise my hand option. And we'll try unmuting you so that you can ask your question. Ideally, all the questions will be taken at the end of the talk. Now, I know I've given an introduction, but I haven't introduced myself. So my name is Pratik Bihani. It's my parents' company that was started 30 years ago. It's called Eklavya, and I've been working with them for the last 10 to 11 years. And it's been a good experience. So I come from the management's perspective, and a lot of speakers here are speaking with experience as employees. So there are people in the talk who have been working on their own as well. So it will be a good mix, both from the perspective of the owners or the management, as well as the employees. So it's going to be a good mix of talks. Now, to introduce our first speaker, we have Ms. Shraddha Surana. She's the lead data scientist at ThoughtWorks. She's been associated with ThoughtWorks for the last 7 years. She's worked in a company called Mu Sigma before that. Machine learning and data science are something that she loves, and she's been given a lot of talks. She's been invited for talks across the world, and she's held a lot of workshops, and she's done a good job. A lot of papers have been published, and I think she's the right candidate for giving this talk. Her title is The Subjects That You Thought Are Not Important, but they turn out to be important in the real world. So I would like to hand it over to her. You feel free to ask her questions. And of course, you can pressurize her to give a talk on data science. We can accommodate her on one of the weekends if you're interested. So over to you, Shraddha. And you can share your screen, and if you can give a short introduction about yourself, that'd be good.
Thanks, Pratik. Hello, everyone. So Pratik has already given quite an introduction for me. There's nothing much that I have to add in there, other than the fact that I'm really interested in everything data science. So I think with that, let's start with the talk. Let's dig deep. I shall just share my screen, and also Zoom etiquettes. If there are any questions, please put it in the Q&A. I will try and look at those and answer those at the end of the session. Some of them I'll answer live. Some of them I will then reply on the Q&A itself, depending if there are a lot of questions. Yeah. So let us start with the question why. So as a student, I definitely had a lot of whys. in most of the subjects that I studied and the problems that we had to solve, I understood the how part very well, how to do a particular thing. So if we had to apply some compression technique on something, I knew very well how to apply it and everything to any given problem statement. But why would I apply it or think that a particular solution is applicable to a problem statement? That part I did not really understand. So given a problem statement, like given a question in a question paper, I could implement a technique. But the thing that I found lacking, or the thing that was very disconnecting to me, was I would not be able to identify the problem statement in the real world. Like technique to apply kar lungi, but on what problem statement? That was one of the major whys that I had when I was a student. So yeah, one of the questions that I and many of my colleagues also had, and from what I understand interacting with students now, is that this question is still quite relevant in the sense, why am I studying this? I definitely had this question. Why am I studying this? Is it even used in the industry? Who uses this in real life? And well, after 10 years of industry experience, I can say I have finally figured it out. The answer is, people do use the fundamental concepts taught to us, especially where some real thinking needs to be done. So there are a lot of problem statements that tools help solving. But once you reach a level where you want to start innovating something, not just using a tool, but understanding the code to be able to better it. Like when you're solving problem statements, there will come a time where just using a particular tool or just using a particular library is not enough. You'll start realizing limitations of it, and that's when you want to go ahead and be able to modify it or make improvements on it. And that's when the actual fundamental concepts that we study actually come into use. So I'm a data scientist with an engineering background. I did my engineering in electronics and telecommunications, my bachelor's, and I did my master's in computer science. So any domain, people studying in any of the engineering domains can actually switch to data science. And this particular talk will be a little from the data science perspective and a little biased towards electronics and computer science, since that is my background. But I hope that it will expand to the other domains as well. And I've tried to figure out some other use cases as well. So let's go into one of the main topics that I think is very, very useful as a data scientist is mathematics. So this is something that the first years would have, and I think it goes on even in the second year. And even in master's course, mathematics is a subject that is taught. And there are many concepts in mathematics that are useful in data science and in real world in general. And I think one of the topics which is given not as much importance as it should, because it's just so useful, is distributions. So there are many distributions, and we learn many properties of these distributions. And at the time, we don't really think of applying it in real world. We just study them. So I'm sure many of you would have studied Gaussian distribution, would have studied Poisson distribution, would have studied exponential growths. But most of the time, it was limited just to the question paper, right? So actually, if we really want to understand these distributions, so for example, the exponential growth, given that we are in this COVID situation, the pandemic going on, why is it called a pandemic? It is because of the exponential nature of the growth of this particular spread. So there's a huge difference between how many people would get infected if it was a linear distribution, if it was a linear growth, versus it being an exponential growth. And understanding this simple fact can help a lot in identifying what precautions should be taken. So why is isolation one of the solutions, right? It is simply because it helps reduce the rate at which something grows. And in all the news channels, when we hear flattening of curve or linear growth, that is actually very good, given that without any precautionary measures being taken, this would actually be an exponential growth. So that is the figure on the right hand side, which is there. So distributions play a very, very important role because they are the starting point of any analysis. Even to figure out which analysis actually fit a particular problem statement, the data distribution is something that needs to be understood, because the kind of analysis that can be done changes depending upon the distribution. So if there's a Gaussian distribution, it's a different type of analysis we would go ahead with. If it's an exponential distribution, it's a different type of analysis we would go ahead with. Then there is probabilities. Again, a very important concept, and is used in a lot of places. There are even specialized fields, probabilistic distributions, probabilistic graphical models, which are there. So not only the very basic probability, but if you go one step ahead in Bayes distribution and everything, it will really help to understand the, so conditional probabilities is one thing which is, I'm sure, is thought. Um, so understanding that itself helps in more of problem formulation and understanding the dependencies between variables and everything which is there. Matrices is something that is very important. A lot of you would have heard about deep learning. So whenever artificial intelligence and machine learning is heard of, people have heard of deep learning, which is a type of, which is the whole domain of artificial neural networks and its different types. And the internal workings of it make heavy use of matrices. So understanding the linear algebra part is also very important. Statistics, of course, for any sort of statistical analysis, any research that needs to be done. More importantly, to be able to identify whether the conclusion that we are making is significant or not, or is it just random chance? Like I can just say a statement and say that, okay, this has a p-value of so and so, but what does that really mean, right? So these all are very important, and FFTs and calculus also come very much into use. Although I have to say that in all my years, I haven't used FFT as much as the top four. But there was this one particular problem statement which was actually in language translation. And in that case, we did make use of FFTs, and it very much eased out our lives. So mathematics, definitely, although I'm sure given that the whole data science domain, mathematics is a given. How much deep you go into it is up to you. But at least the top four are very, very important, and do pay special attention to them. Then another thing that I came across in one of my projects and immediately made me think about one of the subjects I had in college was signals and systems. So this was actually a price optimization problem statement that I was working on, which basically is to figure out which is the optimal price to put on a product so that it is not too high that your customers will not buy a lot, and it's not too less that you're not making enough profit. And in order to do so, one of the things that had to be done was to figure out future sales. Now, when you're thinking of future sales, there are a lot of years of sales receipts that are available, which can be analyzed. But there are various different components that go into the fact that a product has been purchased. Right? One of them is trend, which if you look at the right graph on the screen, say if the top row was the sales data, and so it's just the top row which is available to us, the sales data over a period of time. However, that data is affected by two major factors. One is the seasonality and one is the trend. So for example, ice creams will sell a lot more in summers. So that seasonal trend will be visible. On the other hand, there can be certain food products that just start trending. And one of the main examples that I always think and cite is the makana. Earlier, no one would even have it. In fact, if it was given in anything, people would remove it aside. But once its health benefits were discovered, now we actually have different varieties of them in supermarkets. So that started selling not because of its price, but mainly because it just started trending. So these are two things that we want to remove from our data, which actually is a signal, if you have a look at it. And the way to do so, at least to identify seasonal components, is to use autocorrelation. Now, this is something I, for some reason, distinctly remember studying in one of my subjects, signals and systems. I could solve the problem statement, but at that point in time, I could not really connect that, okay, autocorrelation is used in something. Most likely it was used in telecommunications that time. But so I did have the disconnect. I could solve it. And this is when I actually made the connection that it can be used to identify seasonality. So on the left-hand side, the graph that you see, that is figuring out the frequency or the seasonality using autocorrelation. And I won't go into the depths or into the technical, but looking at this graph and seeing again when the graph turns from negative to positive, that is the seasonality which is there of that particular signal. And one of the things that I also realized that most of this data, especially the time series data, can actually be seen as signals, and all the concepts that we can apply to a signal can be applied on the data as well. So for me, that was a wow moment, and I did wish, so I still have my notes, by the way, from 10 years ago, more than 10 years ago actually now, of signals and systems. And I really, I sometimes feel I need to go and revise all those concepts, because I might figure out different ways of analyzing my data and looking at them in terms of signals. One of the other subjects was coding and data compression. This was actually taught to me in my bachelor's itself, but it probably be taught in the computer course as well. This was important in general, especially nowadays, because we're dealing with huge amounts of data. So to understand lossy and lossless compression becomes very important. There were quite a few encodings also we had learned, like Huffman encoding and stuff. And one of the things that I realized that translates to is embeddings. So in the deep learning space itself, there is something called embeddings, which is representing the data into another form, which has more information inside it. So those are called embeddings. Sometimes it's also to translate non-numeric data into numeric data. So translating sentences or words into numeric representation, which can be given for modeling purpose. So those are embeddings. And I realized there are many similarities between the encodings and compression techniques that I had learned and what I'm looking at now in the real world. So actually, these were techniques that were not present when I started off my careers. So we learned all of these concepts in coding and data compression more from image processing and signal processing point of view. And when I started off as a data scientist, these techniques were not as such used. And recently, I'm seeing a lot of concepts that have their foundations in these techniques. And that's when I realized that being able to map what I've already learned to my problem statements is very important, not only to understand the new techniques that are coming, but also to be able to come up with those new techniques myself. So let's switch to non-electronics and non-computer domain. If you look at chemistry, bioinformatics, cheminformatics, or the life sciences space in general. So everything is data now. Whatever you see around you can be translated in some form into a data. And if it gets translated into a data, you can do some research, some science on it, or build some model onto it. However, the key thing to remember is that data belongs to a domain, right? So by the way, so artificial neural networks, which are the building components of deep learning, were actually inspired from the biology domain. So the way the brain works, the neurons and the connections that it makes, that was the inspiration for building the artificial neural networks. What I want to highlight over here is that even though the concept actually came from bio, it was applied into another domain, and something as wonderful as artificial neural networks was generated, which is now a big bang field in itself, right? So, sorry, just a minute. So one important thing to remember, at least for data science, is that data science is one of the fields which is not complete on its own. So you can't just do data science. You may be able to study the concepts, the algorithms. You may understand how to handle data, how to deal with missing values, how to impute the missing values. But the data belongs to a domain. And in order to be able to correctly interpret the numbers, we need to have some idea of the domain as well. So that is where having the domain knowledge of anything that you are currently in can be useful. So for example, as a data scientist, you can end up working in any domain. I worked in the astrophysics domain last year, and this year I'm working in the life sciences domain. So all the chemical and biology concepts that I had learned actually in junior college are coming back to life now for me. So how amino acids are, what are amino acids, and the fact that they are building blocks for protein structures, and how the structure of the protein actually determines its functionality. So all of this was some part of it. We had chemistry as a subject in our first year of engineering, and some part of it from junior college. So all that stuff came up. So whatever you are studying, whatever domain you are studying, if you actually want to go ahead and research in that particular domain, you will most likely be using a lot of data science concepts, a lot of machine learning and AI, and you need to apply it to some domain. Like it's more of an application, or I think of it as a tool. So you can arm yourself with those tools, which you then have to apply in some domain. So that could be the bioinformatics domain, that could be chem informatics domain, it could be chemistry, it could be the mechanical domain. Because once you know the domain, you are master of the domain, and now you can apply those concepts. Or you can be a generalist. So I don't work in one domain only. I see data science and machine learning as tools that I have to apply in any domain. But whenever I do that, I need to go a little deep into each of the domain that I'm looking at. So it's very important, whichever field you are in, if you just pay attention and try to figure out how to match it to what you want to do. Image processing was one of the subjects, and the way that that has been useful, even small things like identifying edges and corners in an image, they are now part of the whole feature engineering, which is basically extracting features from data before we give it to a machine learning model. So for example, convolutional neural network, so it makes use of the sliding window concept throughout the image, and this is something that I remember studying in my image processing classes. Only if I would have been able to figure it out how it actually applies in real world, and get rid of the disconnect which was there, and try to figure out what sort of problem statements I can actually use in, I think I would have a shot at coming up with it. Another subject that I found very useful in my career is digital electronics. And this is simply from the flow of information and logical thinking perspective. So when we are modeling, it is basically data that is going from one place to another. So in this particular figure, you can see A, B, and C as the inputs. Over here, it might be just a binary input 0 or 1. In a real world, it could be a larger set of data which is there. And this subject really, I think of it more as it helped train my brain to understand how the flow of information is, how data can interact, and how to keep track of it. So I don't want to go into complexities of it, but when building a model, and especially ensemble model and assembling them together, this becomes very important. Computer networks. So coding is not all that is required for building a software. There are many other considerations as well, which depend on the criticality of the application. You can build the code, but in order to deploy it, I think computer networks is one of the concepts that does come into play. You might have various service level agreements when you're dealing with a client, and things that need to be responded to in a specified time, or certain procedure that might need to run within a specified time. So understanding computer networks and minimizing any delay from network point of view can also be very important. Then I thought I should put in something about instrumentation and mechatronics and all the fields related to it, because they are very important considering from IoT and robotics perspective. Given that we can actually store a huge amount of data and all the network bandwidth has also increased, IoT has risen a lot. So IoT is something that is being researched in, and more companies are starting to leverage it. Mainly because it is interaction with the real world, right? So your sensors and everything are in place, and a lot of data is being collected. Um, the amount of data that can be collected and stored is huge. So there would, again, the kind of questions that you should actually ask over here. So I'm not going into the actual IoT and robotics and how the mechanics of it work, but what can you do from a data science perspective or from the data perspective? Because at the end of the day, you would be collecting data from these, right? From IoT as well, or from robotics, whatever is the robotic application as well. So several questions might arise, and it should arise, which you should ask yourself or your teachers and professors, as in where to store the data, how do you store the data, how do you connect to the database to store that data? Should you at all be storing all the data, or should you compress the data and store, or should you aggregate the data? For example, just take, say if your sensor is gathering data every 15 seconds, do you need to store that whole data, or can you aggregate it, take an average over an hour and just store that one particular data? And how long should you keep the data? Do you need to keep it for eternity? Can you just take the aggregate and store the aggregate, and thus saving a lot of memory space that is required? Or do you need to store it, say, for 2 months or something from some legal perspective? These are the kind of questions that you would want to ask when you're thinking of data and IoT and robotics. So even in robotics, like reinforcement learning is one of the famous machine learning applications which are quite used in the robotics domain. And if you're interested in mechatronics and instrumentation and robotics, but you're also interested in machine learning, then that is one aspect that you can actually think of, because it meets both your requirements. So domain is very important in data science. Like I had mentioned earlier as well, you cannot work with data that does not belong to any domain. All data belongs to some domain or the other. It could be oceanographic data that you have, it can be astrophysics data that you have, it can be any data. And when you're working with it, you need to understand some part of it. So what you're doing right now in engineering course is actually building up your domain, so that later on when you're working with any data belonging to that domain, you will be a step ahead compared to those who are not from that particular domain, right? So identify your interest, and I would say figure out how you can use your current situation to create a bridge to where you want to be. So what I mean by this is, say if you're studying engineering and for whatever reason you actually want to be a musician, so try and figure out how you can bridge the two. So if you're in electronics and you're also interested in music, then there is a lot of, I do not know the terminologies and all, but there's a lot of mixing and stuff that can go on from electronics point of view and from software point of view as well. The key over here is to identify your interest, identify that this is where you are, and ABC are the things that you need to do in order to get where you want to be, or even figure out how you can actually merge the two, because that is the ideal situation. You're already doing something, you're interested in something else, so you want to merge them. On the contrary, if you're already in the domain that you want to be, that's great. You can expand your horizon by seeing what are the things that can add to your skills in the domain. And data science is one such skill that I see will be useful everywhere in the future. So everything is data if you look at it. So if your interest is music, you can actually extract data from the music. There was one of projects we did, which was in the audio domain, and that involved really understanding the different parts of the audio, the different patterns in the audio, and how we can extract features and what we can do with it. So there are various music analysis that can be done. You can also create music now. You can train some machine learning models on the music that you give, and it will produce music for you. Or if you're interested in writing, so you can think of creating models that can actually take in input from written textual, which is there, written text, which is there. And there are different type of analysis that you can do with it. For example, one of the analysis that was done is a model was trained with textual content and the author. And then post that, when a new content was given, it was able to identify who's the author. So there are various things that you can do from identifying the genre of the music in the earlier case, or the writing in this case, to also creating a new piece of writing. So there are models that have been created where you given some textual information, you train it, and then it will actually give out some piece of textual information, which sometimes makes sense, sometimes is just fun to read. Astronomy and astrophysics. There is a lot of data out there. There are lots of telescopes that are placed around the world. There are optical telescopes, there are radio telescopes as well. These collect enormous amount of data. So if you're someone who's interested in this space, you can see not only studying the concepts of astronomy and astrophysics, but figure out what you can do with the data. Also, I would say get in touch with institutes that might be around you, because they might actually conduct courses or give lectures around this space. So that also helps you build your domain, and you can figure out what you can do with the data. Drug discovery. This is a hot topic now, given that we all want to be able to generate vaccine for the COVID. In this case itself, all the proteins and amino acid data are actually available. And the good part of living in today's generation is that a lot of the data is open source. So you don't have to pay for the data, nor do you need any special permissions or anything. A lot of the data is made available online so that people can actually model on them. So if you're from the chemistry background, bioinformatics background, there's still so much you can do if you understand the data science concepts, and if you're able to relate what you have learned, understand the core fundamentals, and understand how you can use it. So cross domain, I think one of the most important things that I have realized is the start of path to invention is cross domain. So a lot of things that are a norm in a particular domain, when taken to another domain, they become inventions. Artificial neural networks is a great example of that. It was actually a concept in biology that was then taken over to computer science and the whole data science space. And now it's a field on its own. And I think the only core thing that is required in this is your attention. So if you're just attentive in what you are doing, understand the core concepts thoroughly. So for example, in data compression, if you actually understand the concepts thoroughly and are able to map it to some real world problem statement, when you actually go to another domain, you might be able to take those same concepts in those domain. And the benefit is that you bring a new perspective to an existing problem in that domain, and you'll be able to suggest something that is not the norm. So it's something new in that domain, which means that you are inventing something. Uh, I think a lot of invention actually lies in cross domain, taking ideas from one space which are common in one domain to another domain. Since you already have the background, you have the confidence of the solution, it has worked in a particular domain, and hence the confidence of taking it to another domain is also higher, rather than just trying to invent something from scratch. So one of the key things that I want to say is everything is useful if you know how to use it. Whatever you're studying currently can be useful if you know how to use it. Just a second. Yeah. Right. So everything that you know will be useful if you know how to use it. If you're in the mechatronics field, you can extend it to IoT or data science that you want. If you're in the mechanical field, I'm sorry, I do not know much about the mechanical, although I did do one project during my master's. But even with that, um, I know there's a whole study on flow dynamics, which would also involve a lot of data at the rate at which some liquid is flowing or something. And there's a lot that you can do with that as well. So as long as you're attentive, everything will be useful if you understand the core concept of it. And another thing that I want to say is take a pause to stop and think. Uh, this is extremely important. So we are in an era with so much information around us. It is but natural to try and assimilate everything. That is for me, back in the days when I was doing my master's, it was to go through as many courses as possible. So I used to take courses on the Coursera and other online platforms when they just started, or even videos when these platforms did not exist. So my whole agenda was to take in as much knowledge as possible, because that would mean I have so much information which will be useful, right? But what I didn't do was to take the pause to stop and think and map it to real world. So I'll give you an example. I was very much interested in game theory. So I took a course on it. I completed the course. I went through the course. I took the videos. I took the quizzes, etc. And one of the things that was taught in there was prisoner's dilemma. So prisoner's dilemma, to give you a very short explanation about what it is say there were two partners in crime and the police has caught both of them. They are put in two separate interrogation rooms, and they have been given an option that either you confess to what you have done, and if the other person doesn't confess, they get 15 years of imprisonment and you walk out scot-free. And the same deal is given to the other person as well. uh, but the catch over here, which they don't know about, is that if neither of them confess, um, they both get to walk away. They both get only 1 year of imprisonment. And if both of them confess to their crime, then they get 10 years each. So if you think about it, the best course of action is for both of them not to confess, so that they both get only 1 year of imprisonment, right? But then um, prisoner A will think that, hey, if I don't confess and the other person confesses, that other person goes scot-free and I get 15 years of imprisonment. And the same the other person also thinks. So both of them end up confessing, right? So this is the prisoner's dilemma. And this is something I took at that point in time. I understood the concept and it was done and dusted with. But what I did not do was to take a pause, think of all the real life cases around me. And the real life cases, recently when I stopped and I was thinking how all these concepts actually apply and where I can apply them. One of the things that occurred was countries and their defense systems, right? So if everyone observed, now every country is prepared, they invest heavily into their defense systems so that they are prepared if the other country attacks. But if all the countries decide never to attack, to call it a truce, to call it peace, countries will not have to invest so much money in defense, which means there is a lot more money to create infrastructure and for a lot of other purposes, for research, for anything else that is required. But if a country does not invest in their defense, then it is sort of open to attack by another country, and another country might take advantage of it. And everyone knows that. So everyone ends up investing a lot in defense and to keep it up. So this was a classic case of prisoner's dilemma that I realized is happening in real world around me. And when I relate it to real world, that's when the concepts become even more stronger. And that's when now when I see a particular problem statement, I'll be able to think of it and define that problem statement as being in the prisoner dilemma domain and then be able to work over it. So do take a pause to stop and think of the concepts that you have learned and how it applies to real world. And that's all. Thank you for your time. I'll have a look at the question and answers now. Some of them I'll be able to answer live if we have time, and others I will try and respond in the Q&A itself. Thank you.
Thank you, Shraddha, for a very detailed presentation. Before we go to the others, I have a question. So you perhaps have listed about 10 odd subjects. In engineering, I remember studying 40 subjects. So are you trying to imply that the remaining 30 subjects were absolutely useless? I shouldn't have concentrated on that.
I'm sure I can find something interesting and relevant in those subjects as well. But two things. One, if I went through each and every subject, it would take a lot more time than half an hour and 15 minutes of Q&A that I had thought of. And two, I don't remember all the subjects. Okay.
So basically they weren't important, right?
I don't know. I might remember the concepts.
Okay. So does anyone have any questions? I think some people have raised their hands. Can you just raise your hands again so that I can unmute you and allow you to talk?
So I see one question. What prerequisites are necessary for learning AI and ML? So I'll go back to here. This is a major prerequisite, I would say. Mathematics, or at least part of mathematics. Distributions, definitely. Probabilities, definitely. Matrices and statistics, definitely. And then, so these are the basics that are required. Fortunately for us nowadays, we don't really have, we don't need to implement all the algorithms from scratch, because a lot of libraries are available and they are very much optimized libraries as well. So we usually just go ahead and use those libraries. But at the same time, it is important to understand how to use them. So the concepts are still necessary. But as far as prerequisites are concerned, I would say these definitely are, and calculus as well. So I saw a simple doubt: which side should I focus more, stats or coding? Stats, I would say you definitely need to understand the core concepts, because that will be your bread and butter. Coding also is required, but you don't need to be really good at coding. That's what software developers are for. They need to be able to optimize their code and everything. But the kind of coding that we would require is a little different. We might need to understand the coding enough to be able to optimize our algorithms. So for example, a lot of loops are there. So if you run a for loop for everything, it will take ages for your model to run, for your code to run. So there are techniques like vectorization and everything that you would need to pick up along the way. I hope that answers the question. Okay. So Pratik, I'll just take these questions one at a time, but if the time is up, do let me know. In that case, I will type out the answers.
No, I think you can just take it forward because there are a lot of questions coming in. So
Yes.
I think it's good if you can answer them live.
Okay, then one is, should I learn R or Python? I get asked this question a lot. So R is a language that has been created by statisticians and is very much focused and easy to use for the whole stats and AI ML part. Python is more from performance point of view. And honestly speaking, it would be good to know both. I have realized for me, R helps in quick and dirty implementation and figuring things out. I find it more friendly as such to code and get the results. However, for productionizing models, Python is the one that is used a lot. So if you absolutely have to pick only one, I would say start with Python, because it has a good community and a lot of libraries that will help you, and a lot of visualization libraries as well. Okay. Then there's one, which software programs would you recommend for the data science field in general? MS Excel, Python, R, Tableau, Power BI are the main players, but are there any lesser known programs that you find yourself using in the industry a lot? I would say no. I mostly use Python. I don't use much of Tableau and Power BI. All the visualizations that I want to create, I also create them in Python and R. I do use MS Excel also if there is, because I find MS Excel quite good. It has some really good functionalities, and there are some things that you can just do very quickly in it. These are the main things that I use. Other programs might use cloud services if it's required, depends on what the client infrastructure is as well. In the previous project, we did use Google Cloud. We use AWS and then the machine learning libraries provided by them, or we used to train over there. So for programming, mostly these are used. And then another aspect that also comes is the actual processing of the data. So your local laptop might not be enough for it. And there are other things to look at in that particular case. I belong to electrical engineering, but I'm studying machine learning and deep learning from last 7 to 8 months. What should I can do further now in today's situation? I think you already have a good start. You are using machine learning and deep learning since 7, 8 months. So I'm assuming you've gone quite a bit, learned quite a lot in that much time. I'm assuming over here you are still studying. So you can figure out how you can apply those concepts in electrical engineering, or how you can combine the two, like I mentioned. Other than that, I don't know what to answer for this particular question. Like I don't have enough information as such. How do I know should I go for ML or not? Because prerequisites are so much to learn again now. Well, I was hoping I take this talk in time so you don't have to learn again, but you learn in the first place itself. I'm assuming this person probably is in the 4th year now or something. That's why I wanted to take this talk to inform you that there are a lot of things you can pay attention to during your engineering itself, so that you don't have to learn again or do some another specialized course later on. But if you just revise those concepts, that should at least be a good start, I would say. And then it really depends on how much interested you are in the field. Like if you're really interested in machine learning, then actually going back and revising your distributions, probabilities, and stats will not really feel so much of an effort. Whereas if you're thinking of going into machine learning only because it is the hype at the moment, then it would feel like an effort. So I would say try doing things that do not feel too much of an effort, because that's probably what you're interested in, and that's probably what you're going to be really good at. Can you talk more about integration, computation, fluid dynamics, and data science? Well, I'm sorry, but I do not know much about fluid dynamics. There was just a bit that I had read about and I had done because I was looking into something in wind tunnels and uh, ZF, the steering company. We were doing something for that. So I have some idea, and I know that the rate of flow and everything is something that is of interest, but I do not know exactly what goes in this particular field. So like I mentioned, this is something for you to figure out what are the kind of data that can be useful in computational fluid mechanics. And you can then do some data science on top of it. So, okay, we have a lot of questions. What can be the building blocks for AI? I am not sure what exactly that means. I shall try to come back to it later. What are my views on ML from Coursera? I think they have some really good courses. Especially the course by Andrew Ng is really good. So that's a course that I had taken before even the Coursera platform was there. He would teach, there were videos of his teachings on the Stanford website itself. So that particular course I do recommend to everyone because he goes into concepts, but he also does not go too much deep into mathematics for those who may not be comfortable with it. So I would say all the courses are quite good, especially Andrew course is very good. There are some courses on edX and Udacity as well. They're also quite good. Any references or courses for AI and ML? Like I mentioned, ML, I definitely recommend Andrew Ng's course. For data science, there is the Analytics Edge on edX. I found that course very useful. So I think these two courses combined are quite good because the Analytics Edge gives sort of a breadth of data science, and the machine learning course by Andrew Ng gives really nice conceptual understanding also of ML. With they have some assignments and everything also. If you do, the understanding gets cleared a lot. And one thing I'd like to clarify is that in a lot of cases where AI is mentioned, it's just really machine learning. So AI is the big umbrella. Machine learning is a subset of it. And machine learning is what is really used mostly. Which would be one of the best way to start the journey in this field. The courses that I just mentioned, that would be good. And uh, the mathematics topics which I mentioned, and figure out a pet project. So figure out where you would want to apply it on your own and try to apply it in those cases. So if you're someone who's interested in music, try to get some music data, apply it over there. If you're someone who's interested in chemistry, there's lots of data available in that domain. You can apply it on that. So after learning the concepts, it is very important you apply it on something on your own, because that will give you much better understanding also and confidence also. Oops, I think I marked some other question as done. Sorry. Pratik, I can go on for a long time, so do let me know when the next talk is supposed to start, and the other questions I will answer on the Q&A screen.
Yeah, sure. I think you have a couple of minutes.
Okay.
So if you want, we can actually switch. So you can switch to typing the answers.
Okay.
Right. Okay.
All right.
So that was a good informative talk.
Thank you.
If you would like to, if any one of you all want to gain some more knowledge on machine learning, you can message and we can have a separate session at a mutually convenient time where we start from the basics and we can dig deeper into a few specific topics as well. Before the next talk starts, does anyone want to ask any question? I see Dr. Bhavna wants to say something. I will just unmute her. Yes, ma'am, you can speak. You're on unmute.
Yeah. Thank you, Mr. Pratik. And thank you, Ms. Shraddha Surana also. It was really nice getting into how various domains could be diverted towards the further research, and typically AI and ML. I think really this would empower the students in the direction towards machine learning and AI. And in fact, it would really solve many of the queries, because people typically think, as far as I know, the students in their era typically think that AI and ML is only for the students from the computer science branch. And rather, it was a very nice thing which you had shown that no, it's anything which could be diverted over there. So it was really, really a very important point of discussion from my point of view.